Welcome back to my YouTube channel. Today we'll be dealing with NCV Level 4. This is a mathematics. We have given question 3. Here we given 3.1, given that the following equation is this. We've given f of x is equals to negative 3 over x. Says determine the following derivatives of f of x by applying the first principle. Show all steps there. All right, we've given that to show that f of x is equals to negative, we have to use the first principle there. Should apply our first principle there. All right, this is question 3.1, right? So applying first principle here, we know that the formula for first principle states that g of x prime, right, it's equals to f of x plus h minus f of x, isn't it? Here f of x prime is equals to that, right, over h, whereby here we have that provided that lim is h tends to 0. So this is what we know so far. This is what we know. So it's up to you. You take it step by step or you put it straightforward, right? That means, okay, we know this will still at this portion of x where we see x, we have x there, will replace x. Where we see x, will replace with that there. You right, you understand that. Let us attack this and show that, okay, this will be equals to, you keep the lim, lim must be always there, right? Lim as h approaches to 0, what will we have there? If you check, we have the fraction there, we'll have minus 3 replaced by x plus h there, right? Then we have minus f of x, whereby f of x is this, is the whole thing, whereby is equals to that, is equals to what? 3 minus 3 over, okay, there's a negative here, isn't it? The original negative, also this, there's a negative, so you'll have, you put your bracket minus 3 over x like that. Then let's not forget the h, we have the h over h, this is what we have. Then we continue like that. We have equal sign when lim h tends to 0. Then there you multiply, there you'll have minus 3, you have negative 3, that when you multiply that will have positive 3 over x. Here we have over x plus h all over h. Then we still have equal sign lim h tends to 0. Then we know this is a fraction, guys. We must have what? LCD, isn't it? LCD, you know the denominator must be the same, so you can cross multiply. At the top you multiply by x, at the bottom you multiply by x, also here you multiply by x plus h, also here you multiply by that. Our LCD there, lowest common denominator will be x plus h multiplied by x, like that. So there will have what? Minus 3 multiplied there by x, right? Then you multiply that plus 3 into x plus h, divide this by what? All over that into x plus h multiplied by x all over this original what? H there at the bottom. So this is what we have. Then mathematically you distribute there, you distribute, you'll have lim sh tends to 0, we have minus 3x plus 3x plus 3h all over there. Still have x plus h into x divided by h. Then as you can see, this and this will cancel. All right, that and that, this and this will cancel, guys. So what do we have here? Lim sh tends to 0. You have 3 there like that, all over 3h into x all over h. But this is the same as what, guys? As division, we'll just multiply by reciprocal. Remember here we had h like that, so we'll multiply by 1 over h. So this and this will cancel there. Understand there? Then you will replace the 0 here. If you replace the 0, there will be plus 0. So our answer there will have, there will remain, here will have 0. Remember, if you substitute 0 there, you'll have what? And also that will cancel, so we'll simply have to 3 over, then x plus 0 is simply x multiplied by x. Here we'll have x squared, so that is what we'll have here. That is our value. Okay guys, by verifying this, you can use the first derivative. You can use this by applying the first derivative. Remember, this is same as negative x over 1 over like that. So this is the same as x minus 1. Multiply there. If you multiply, we'll have x, then you minus what, 2, then you take it that to the bottom. So yeah, this is what we will have so far, guys. So then 3.2 says we have given these the derivatives should differentiate that, right? We're supposed to differentiate y is equals to 5x raised to the power 4 plus 3 over 5 cos 5x plus 3 e4x plus 2 raised to the power of 4. So how can we go about this? So how can we differentiate this? We want to differentiate this, isn't it? So we first have to rewrite. We have to rewrite that. Let me write this at the bottom here. All right. So y, okay, everything, let's check what is that is needed to be. There's something that we have to, okay, everything is fine, so we can simply just take dy over dx, then remember you'll drop the exponents, you'll multiply there. 5 multiply will same as 4. 5 multiplied by 4 is 20, isn't it? Then you minus 1 on the exponent, you'll be left with 3, right? So here we have plus, there we have cos, isn't it? So to multiply, you first differentiate cos, would be negative sign, isn't it? Still here we have 3 over 5. The differentiate cos would be negative sign 5x, right? Then you come again, you differentiate what is inside there, you apply the chain rule again. Also you differentiate that, you multiply by that, will be what, 5. Multiply this whole thing by 5. All right, when you multiply by 5, this and that will cancel like that, as you can see. Okay, let me just leave it for now. This is what you will have so far. So that is what you will have. Let me grab this. So this is what you'll have. Then we come here, check this is a exponential. How do you differentiate? Here we have a plus, we have a 3. How do you differentiate the exponential? You'll take the derivative, you'll multiply by the derivative of the exponents, whereby will be what? Will be 4 there, right? Then you rewrite this as it is, power of 4, then multiply this by ln of the base. But if it's e, same here, it's e, simply 1, so there's no need for us to rewrite this. Will simply be like that. Then this is a constant, simply what? 0. So yeah, this is what you have so far. Okay, this we have 20x raised to the power of 3. 5 and 5 will cancel, will be plus. Now we'll have to 3. When you multiply, there will be negative 3 sine 5x. This and that, 3 multiplied by 4, which is 12, right? We'll have there plus 12 for e raised to the power 4x by, yeah, this is what it is. That is how you differentiate the first part there. So yeah, this is how it goes. So we have again here y is equals to 5 over x raised to the power of 3 minus 2 ln 5x plus 3 over 5 root x raised to the power of 3 plus 5x, like this. Supposed to differentiate all of this. All right. Supposed to differentiate all of this. So if we differentiate this, we're supposed to, let's first place our thing in order. Let us place our thing in correct order. If you take that, would be negative 2 ln 5x is fine. Also here we have plus. Let's try and break our thing there to be in order there. Okay, 3 over 5 is fine, but this, the square root of x raised to the power of 3 is the same as what? Like this, it's the same as x of 3 over 2, right? Then if you take it up, at the top will be negative, so this is the same as x minus 3 over 2 plus, take a note, the square root is 5 and x. This is, the square root is for both, we have squared both x, 5 and x. So if you have that, guys, it's the same as square root of 5, right? It's the same as square root of 5 multiplied by the square root of what? Of x. Hopefully understand this. And then this is the same as square root of 5, but that is same as x 1 over 2. So you're supposed to understand this. This will be the square root of 5x 1 over 2, right? So now everything is good. Now can differentiate applying our power rule. Drop the exponents there. It will be 5, it will be negative 15, obviously. Negative 3 multiplied by 5 will be minus 15. You would minus the exponent, would be minus 4. Then here we have what? Ln, we have minus 2. Remember, how do you differentiate ln? If you have given to differentiate ln, for example, this will be what? The derivative of, let me just say u, for example, let me just say u. This will be the derivative of u divided by u. You see, you differentiate this, then you divide by it. So if you apply there, you'll have ln. You wanted to differentiate that ln 5, you'll have what? Multiplied by the what? Derivative of 5x will be what? Will simply equals to 5 over what? 5x over this 5x. But however, this and this will cancel, but okay, no problem. Yes, that will have them. So okay, then here we multiply our power rule, will multiply this there. As you can check this, you can see there will have minus 3 times that, which is 9. We'll have 9 over, multiply by 2 there, 10 like this, x there. Basically we will have minus, here we have minus 3, you subtract 1 there, you subtract 1 there again, you'll have minus 5 over 2 plus, multiply there, simply have square root of 5 over 2, then you subtract 1 again, you'll have x, then you have negative half, obviously 1 over 2. So this is what you have there. So since they said you should leave your answer in what? Positive exponents in your sets, if you leave the following answer in what? In positive exponents and sets form, be applicable. So you should not just leave this answer like that. You want to be positive exponents, you will have minus 15 over x raised to the power 4. Take this to the side, will be positive, then there, this and this will cancel, will be minus 2 over x, then here we have negative 9 over 10. It's the same as what? Negative 9 over 10. It's one and the same thing. We have negative 9 over 10. Then this must write this as a positive exponents. That will be, you will take this, that will be simply multiply, is the same as x, same as this 1 over x to the power 5 over 2, right? But you can write, 5 over 2 is the same as what? You use your L, it's the same as square root of x raised to the power 5. So in all that is simply just the square root of x raised to the power 5 plus, then this is negative exponent, still have square root of 5 over 2 multiplied by 1 over, like that. This is what you have there. Then then your answer, yeah, simply have minus 15 over x raised to the power 4 minus 2 over x minus 9 over 10, right? 3 that plus square root of 5 over 2 root x. So yeah, this is what you will have there. This is how you go about calculating this. So here we have again y is equals to like that, into x squared plus 5. So here guys, you'll simply have to, as you can see there, just distribute this there. If you distribute, there will have x raised to the power of 5, right, plus 5x raised to the power of what, 3. Then you can simply now take dy over dx of that. Drop the exponents, will be 5x, you subtract 1 will be 4. Drop the exponents, that will be 15, minus 1 will be 2, like this. So this is what it is. Then let's check this one again that we have there. We have now y is equals to x squared plus 5. Okay, you can still use the same direct man. Drop the exponent, there will be 4, right? X squared plus 5, subtract 1 will have 3. You multiply by the derivative of the inside, there you will drop the exponent, will be 2x of the constant 5 will be what, plus 0. This will simply cause y. Okay, remember this supposed to say there, look, I forgot to put, look there, it's supposed to say, obvious, you've given y is equals to x raised to the power of 2 plus 5 raised to the power of 4. I suppose to say dy over dx. I must take dy over dx. Dy over dx first, multiply by 4, right, subtract 1 will be 3, then multiply by the derivative of the insides. Then when you differentiate, you start differentiate, 2x will be what, is 2. You drop the exponent, you subtract 1 will be 2x. Differentiate 5 is just a constant, is plus 0. Then the answer there will be what, will be 4 x squared plus 5 raised to the power of 3 multiplied by 2. So if you want, yeah, you are done. If you want, you can simplify further, multiply these 2 there, which is 8x. So yeah, this is what it is, guys. So thank you for watching now, and then please do not forget to subscribe to my YouTube channel if it is your first time watching my YouTube channel. And then please, if you have not subscribed, please subscribe and click the notification bell so that you will be notified whenever I post a new video. Thank you for watching.